Okay, good day, my beautiful student. Stay on this topic called periodic motion. But in this video, I am going to divide this topic into parts. The first part is going to be on the displacement and the concept of this topic. The second part is going to be on the acceleration of this topic, of this motion. And the last part is going to be on the period and the frequency of this motion for better understanding. Okay. Now, when you look at this topic, it's all about what a periodic what motion. What is periodic motion? Any motion that can repeat itself. Any motion you see, you observe, and you see there is what continuous repetition of that word motion. Such is called what a periodic motion. Now, take for instance, we have the one on the board, which is what a body moving in a circular form. Is it part of periodic motion? Yes. Why is it periodic motion? Because you can see if I release this body from this point A, and this body happens to move like this and get to this point, it will repeat again and get to this point and repeat again and get to this point. I can say that the body is moving in a circular form, and also the body is undergoing what we call periodic motion. Okay, now we call this thing a periodic motion because of the period of the motion. Period means time it will take this body to complete one cycle, one full circle. You can see from here, the time we start reading to what? Get to this point. The time it will take this body to move a whole circle is called what? A period. From there, we can have so many periods, okay? And that is the reason why the topic is called periodic what? Motion. Now, if you look at this, see what happens. I want to consider this motion on the s-axis, the periodic on the s-axis. Why? Because of if I leave this body here, you can see the body is having a complete displacement, which is amplitude, the radius of the circle. Okay, amplitude is the maximum, the highest displacement of the body. So the displacement still remains the what? The amplitude. Okay. Now, when this body moves from here to here, if you trace it on this s-axis, which I have done here, you are going to see that what? The displacement is from here to that point. The body has shifted, the point has shifted from here to here. When the body is here, you are going to see the displacement is at this point, which is from here to here. The point has shifted from here to here, here to here. Can you see? There is movement, change of the position on this s-axis. When the body is here, see the displacement is at the center. When the body is here, see the displacement from here to the center. You can see when the body gets to this point, this displacement is from here to the center. When the body is at this point, you can see the displacement, which is S, is now the radius from the center to this point. Now you can see this point has shifted from here to here. When the body is here, see what happens now. The displacement is from here to here. You can see the point which was here now is now going back to this side. Okay, so you can see, if you observe very well, you see that what? There is motion or shifting of points along this axis. So that is the reason why I said I can consider this motion on the what? S-axis. Motion along the what? S-axis. Moving from here to here, from here back to this place, from here to here, when the body is moving in a circular form, which makes this thing to be a periodic what? Motion. Okay. Now let's see what happens to the displacement. If you look at this, when the body moves from here to here, I can trace out this triangle. Okay. Now this triangle connects the displacement of the body and the amplitude, which is the radius. Now, if I bring it down, I am going to have something like this, a triangle in this form, okay? Where here is our x, here is what? Theta, and here is what? The radius, which is also the what? Amplitude, okay? Why did I say amplitude? From here to here is the maximum highest displacement, which is also the radius, okay? So the radius is the same thing as the amplitude. Now, if you look at this triangle, you see that we are given this side, which is adjacent, and what? Hypotenuse. What is connecting adjacent and hypotenuse is cos theta. So you can see cos of what? Theta is equal to what? Adjacent over what? Hypotenuse. Which I can say that cos of what? Theta is equal to adjacent is what? X over hypotenuse is what? A. Okay? Or I can use the word R. Okay, so if you want to get your x, which is the displacement, x is equal to this over 1, if you cross multiply, you are going to have r cos of what? Theta. Okay? R cos of what? Theta. Where the displacement is equal to r cos of what? The angle. Now, this is the displacement of what? This body. So x is equal to r cos of what? Theta. Now, remember, I can call this equation 1. And again, to modify this equation, theta is given as what? Wt. Okay? So this x is also the same thing as r cos of what? Wt. Somebody can also say that x is equal to what? A cos of what? Wt. You are still correct. You understand? Because r is equal to what? A. R is the radius, and radius is also the what? The amplitude. Okay? So these equations are the same thing. And this is what? The equation for the what? Displacement of this body undergoing periodic what? Motion. See you in the next video, which is what? The acceleration.